Hi there guys, and welcome to video number 77. This video is on solving simultaneous quadratic equations. Now the keywords here are simultaneous, quadratic and intersection. Simultaneous just means at the same time. Quadratic is when you've got an expression that's got a squared term in it, and intersection is where 2 points meet, or 2 lines meet at a specific point. It could be a curve and a line that meet at a specific point. And that's what these are. All right. So it's important to understand that this is what you're finding when you're finding the answers to these. You're finding the points of intersection between the curve and the straight line. All right. Because one of these equations will be a quadratic and one of them will be a straight line. Okay. And you'll understand that more when we look in the graphs section, when I do the graphs videos. So if y equals one expression and y equals another expression, then make the expressions equal to each other. If they don't, then you need to rearrange and then make them equal to each other. The point is to eliminate a variable and solve for that one, and then rearrange the equation to the general form of a quadratic. Solve using the appropriate method, depends what type of quadratic it is. Sub your solutions back into the easier equation and find the value of the other variable. Then you can check in the other equation again just to see if it works out. So if we're going to do this first one, the good news is that y is equal to this expression and y is also equal to this expression. This is our quadratic. If I drew a little kind of graph, quadratic graph here, okay, let's say that's our quadratic, might not be. And then this is our straight line. Let's say it's like that, right? Not to scale at all, right? There's our 2 points of intersection between the line and the quadratic. So there's going to be an x and a y solution here and an x and a y solution here. That's what we're getting when we're solving these. All right, I'll just get rid of that so I can do all my working out in that space. Now, we can make this one equal to this one because y equals this and y equals this. So x squared plus 6x plus 7 is equal to 5x plus 9. All right, now we know this one's a quadratic and we want to solve it in that way. So we might be able to factorize it. And if it's a non-calculator paper, we'll definitely be able to factorize it. And we just take away the 5x and we take away the 9 from this side to make it equal to 0. So that's 1x squared. Take away 5x from 6x. That leaves us with 1x, so plus x. And then take away the 9 from the 7. That leaves us with minus 2. And that equals 0. Factorizing this is just a grade 5 factorizing now. X in one bracket, x in the other, plus in one bracket, minus in the other. Decide on the pair of factors for 2. 1 and 2 are the only factors of 2, which one's positive, which one's negative. All right, we're going to make a positive 1, so that must be a minus 1 and a positive 2. So 2 and 1 goes in the brackets like that. Therefore, x is equal to minus 2 and x is also equal to 1. All right, now if we get our y solutions, or if we need our y solutions, which we do because that's part of the same question, we substitute it into this easier equation here. So y is equal to 5 multiplied by the first value there, we try 5 multiplied by minus 2 plus 9. That's minus 10 plus 9, and minus 10 plus 9 is minus 1. So y is equal to minus 1 when x is minus 2. And 1, if we get rid of all of that, we'll just substitute the 1 in. I won't do all the working out for it. 5 times 1 is 5. 5 plus 9 is 14. Okay, I've done that right, haven't I? 5. Yeah, so that's 14 there, right? There's our solution for x and y and a solution for x and y. All right, I said there would be 2 for each, and there are. You might be able to write this as a coordinate value, so minus 2, minus 1, and 1, 14, like that. Okay, that might be something that you're asked to do as well, but not in this particular question. It was just solve, and then we're finding x and y values. Now, in the second question, I can see that this is y equals all of this, but y doesn't equal this. You're going to have to rearrange this one to be y equals, right? That is a way of doing it. So y equals, all we've got to do is take away the positive 9x from that side. So that'd be 5 minus 9x. Now, that term is equal to that term, okay? Because they are both y equals and y equals. So we write it out as 2x squared, and it's more difficult because we've got the 2 in front of the x squared here. Plus 2x minus 8 is equal to 5 minus 9x. Again, we need to make it equal to 0. 2x is over on this side. It's all positive over here. All right? If it was negative, we'd want to put that on the other side and make it positive. But it's all positive. So we're going to add 9x to the 2x gives us a positive 11x, and then we're going to take away the 5, so that's going to give us minus 13, and that equals 0. Now, this is one of the harder ones, so 2 times by 13 is 26, all right? Effectively, we're looking for the factors of negative 26, but just list the factors of 26 and then decide which ones are going to be negative. So 1 and 26, 2 and 13, and there we go, found the pair already, all right? It's, because it's got to have a difference of 11, we're going to have a negative 2 and a positive 13. Are we going to have that? Yes, we are going to have that, because that's going to be 2x squared minus 2x, and that's going to be plus 13x minus 13. All right, let's just section those bits off, and then we will factorize these bits independently. So 2x comes out, x minus 1 goes in, plus 13, and then x minus 1 goes in. So the brackets match, that's good. So what we've got there is 2x plus 13 and x minus 1 all equals 0. There's our factorized expression, the identity to the original expression that we had. And the solutions there for x will be x equals minus 13 over 2 and 1. All right, if you don't know what I've done there and how I've got those, please go and watch the harder solving harder quadratics video that I made. Now we've got those values, and that's 6.5, negative 6.5. Negative 6.5 is an awkward number, right? This would probably be on a calculator paper. All right, so I will just pause that a second, and as if by magic I've brought the calculator in. Here it is. I'm just going to use the calculator to work out what the value of y is, right? Because it's slightly awkward. So I'm going to substitute it into here, into the one that I've rearranged. So I'm going to get my y value straight away. Y is equal to 5 minus 9 multiplied by 6.5, or negative 6.5, that should say. All right, two negatives are going to make it positive. All right, let's just substitute in and see what that gives us. So a negative 9 multiplied by negative 6.5 equals 117 over 2, which is 58.5. So y equals 5 plus 58.5, so y equals 63.5. There we go, there's our x value and y value. So I'm going to write those down over here actually. X equals minus 6.5, changed it from the fraction to the decimal form because my answer of y is in decimal form as well, so 63.5. Or we've got x equals, and let's get the other one, so 1. And that's easier to substitute in, we don't need our calculator for that. That's just going to be 5 minus 9, and 5 minus 9 is, I'll write it down, 9 times 1. 5 minus 9, 5 minus 9 is minus 4. Okay, so we've got minus 4 there. And there we go, there's our two solutions. Again, could be put them in the coordinate if we need to, in the coordinate form if we need to. Now, move myself over, let's have a look at this third and final question on this topic. Identify the coordinates of the points of intersection between the graph x, y equals 20 and the graph y equals 4x minus 2. Now, this graph here, right, if we rearrange this very slightly, we'd have to divide by x to leave us with y. Y equals 20 over x, all right? Now, that's not the nicest thing to do here. In a question like this, and then we make them equal to each other. I'm not happy doing it that way. Well, I'm happy doing it that way, but I prefer doing it a different way. So that's a reciprocal graph, all right? If we've got something over x, all right, the reciprocal graphs look like that. That's awfully drawn, right? But it's a graph that's a curve like that, and it never touches the x or the y axis. Okay, so we've got graphs that look like this. That's that one. So it's not a typical quadratic graph. And then this graph would look like that, okay? Straight line graph. All right, and that's just the points of intersection between the straight line graph and the reciprocal graph. That's what we're looking for here. All right, so it's not overtly quadratic related, but it will be because it's in this video. So what I'm going to do is I'm going to make this term here, or make this a term here by putting it in brackets. This expression is now a term, which I'm going to substitute in to that value of y there. All right, now that's going to give me x, and then this is 4x minus 2, and all of that equals 20. Multiply out your bracket, you're going to get 4x squared minus 2x equals 20, and then get this 20 on the other side. 4x squared minus 2x minus 20 equals 0. Okay, now I'm going to move over here so I've got a bit of space to do things. Right, now let's factorize that. Now it's more awkward to factorize. I'm going to write it up here actually. 4x squared minus 2x minus 20 equals 0. Let's go and split those terms there. Think of 4, let's in fact half everything, because everything does half. Alright, so let's just get rid of that and let's half all the terms, because it just makes it a bit easier. It's a bit cheeky to do, but 2x squared minus x minus 10. There we go. Just makes the numbers a bit smaller to deal with. We'll still get the same result if we solve. We wouldn't get the same result if we were going to factorize, but never mind, because we're solving this, or identifying the coordinates anyway. So we're going to, think of 2 times 10, which is 20. All right, think of the factors of 20. So 1 and 20, 2 and 10, 4 and 5. What pair of factors had to make the minus 1? So one's a negative, one's a positive. That's going to have to be the positive one, and that's the negative one. Okay, so I have the minus 5 and the positive 4, and then split the terms there. So 2x squared plus 4x minus 5x minus 10. Section those bits off. If you don't know what I've done there, that's factorizing harder quadratics again, and then solving them. So that's going to be 2x can come out, x plus 2 goes in, negative 5 comes out, because this is a negative number. Looked at that, looked like it was positive, but no, that's a negative 5, isn't it? Negative 5, and then x plus 2 goes in. So 2x minus 5 is one bracket, and x plus 2 is the other bracket. Okay, and that works. So that equals 0. Here's my solutions. 2, not even going to write it out. I'm going to write out x equals, add the 5, divide by 2, so it's 5 over 2, which is 2.5, or minus 2. There's the 2x solutions. All I need to do is get my y solutions now, and that's y is equal to 4 multiplied by 2.5, which is 10. 10 take away 2 is 8, or y would be, if I put minus 2 in, minus 8 minus another 2 is minus 10. Okay, now if I just check that in the other one, I'd have to multiply my x and y values together. So 2.5 multiplied by, or 5 over 2 multiplied by 8 is equal to 20. That works, because that would give you 40 over 2, and 40 over 2 is 20. 40 divided by 2. And then minus 2 multiplied by minus 10 multiplies to make a positive 20. So that one also works. So the points of intersection are in their coordinate form. You got the x and y's. So x is 5 over 2. That wouldn't matter if you left it in fraction form. Y is 8, and then x is minus 2, and y is minus 10. They are the 2 points of intersection between the two graphs in that question. Alright, without actually having to draw the graphs. We've solved it algebraically using our skills that we've got from all the other videos. It's real tricky one. Definitely got to know a lot of maths in order to be able to do this. But yeah, build up the skills, watch all the videos that precede this one, and eventually you'll get there with this, and it's actually really satisfying. You could get 5-6 marks on these sorts of questions. So yeah, hope you enjoyed it. Please click the link in the description. Make sure you watch the rest. Keep plugging it, keep plugging away. Keep letting people know that this is something that you're using and finding useful if you are. Please don't tell them if you're not. Yeah, let them make their own minds up. If they like it, that'd be great. If you can comment on the videos and let me know of anything that might be more useful for you, that'd be lovely too. So hope you have a decent day. Look after yourselves, look after one another, and you'll see me in the next one. Ta-da!